Hi, I'm Nitya, your tutor at Nityaz Academy. Let's learn light and optics together, step by step. Light travels in straight lines we call rays, and when a ray strikes a mirror, it bounces off. The law of reflection is elegantly simple. The angle of incidence equals the angle of reflection, both measured from an imaginary line called the normal that stands at 90 degrees to the surface. A smooth, polished surface reflects rays neatly, which is exactly why a mirror gives you a crisp image. When light passes from air into glass or water, it slows down and bends. This bending is called refraction, and it is why a straw in a glass looks broken at the surface. Lenses put refraction to work. A convex lens bends incoming rays so they converge to a focal point, forming an image. That single principle powers cameras, eyeglasses, microscopes, and your own eye. Suppose a ray of light strikes a flat mirror at 30 degrees from the normal. The law of reflection tells us the reflected ray leaves at exactly 30 degrees on the other side of the normal. The two angles always match. This predictability is what lets engineers aim laser beams, design periscopes for submarines, and build the precise mirrors inside telescopes. Reflection is wonderfully reliable. Hold a magnifying glass over a page and the letters swell in size. This convex lens is thicker in the middle, so it bends the entering light rays inward toward a focal point. When the object sits close to the lens, your eye receives the bent rays as though they came from a much larger image. Refraction, carefully shaped into glass, becomes a tool for seeing the small world. Let's review the light. Light travels as straight rays. When it reflects, the angle in equals the angle out, measured from the normal. When it crosses into a new material, it slows and bends, which we call refraction. Lenses shape that bending to focus rays and form images. From mirrors to magnifying glasses, these two behaviors, reflection and refraction, explain how we see the world. Great work. Keep practicing with Nitya at nityazacademy.com for free lessons, worked examples, and practice.